assorted other things to make it run. It means that a lot of these are either tricky to set up or not as portable as they could be for oil field applications. So there is a demand, or we felt there was a demand for robust portable units with fit for purpose metrology at a reasonable cost. And that's what was the driver behind why we set off down this route. It was robustness, simplicity, and low cost. How do I get this fiber into my well? When we think about deployment, only high value wells will be able to sustain the cost of a permanent fiber installation. You've got the additional cost of the either a square encapsulated control line with the fiber in it, or a hydraulic conduit that you blow the fiber down. So there's a time to install, and then there's a installation cost in terms of the permanent surface equipment. So not all wells can stand that, and that's why there's been an upsurge in temporary installation methods. These are some examples, some pictures I've taken myself. So there's a cable here with a little FIMP tube where fibers can be installed in that. Or there's the carbon fiber rod that Zeeble offer. And again, the little FIMP tube with multiple fibers available in that particular system. And then right the way through to slickline capabilities, where you can use all your regular pressure control equipment and have fiber within some sort of slickline capability. And not forgetting coil, fiber in coil, or the disposable fiber optic darts that are also coming on the market, where you just deploy bare fiber and it only has to last the duration of the survey, which may be a matter of hours. So we end up with a situation where we've got a lot of choice coming on the market now, becoming increasingly available, where people can run a deployment method of their choice suitable for their well to try and get this fiber across the zone of interest that they're interested in making a measurement on. So we've got flexibility, we do have choice and increasing competition. The cost of these temporary deployment options in terms of the cable, the wire, that's becoming cheaper all the time, more robust. So again, this is starting to become an affordable surveillance method for people. And not forgetting that you can also, at the bottom of each one of these deployment methods, have other sensors that will help bring more information to the table. So we're not saying that fiber is the silver bullet that solves all the well problems. It's another very useful tool in the arsenal of tools that we can bring to bear on a given problem. The surface interrogation units. So there are a large number of surface interrogation units available. When you do a search for distributed temperature measurements, that's the most mature measurement available on the market. There's an awful lot of choice out there. So people are spoiled for choice when it comes to selection of DTS units. There's a somewhat more limited selection for DAS. But how do you wade through all the different ways of getting the measurement and the different techniques used to try and extract information and signal from what you're trying to measure? It is a bit of a minefield, but what we found was that a lot of the instrumentation tends to be at the high end. And so again, this bullet point here, where unit manufacturers tend to get involved in an arms race to develop the highest, best specification unit. And while that's fantastic for high-end applications, the flow applications and the seismic type applications, it's probably overkill for some of the low-end leak detection, well integrity type applications. And I'm always reminded that the bulk of the well stock out there does have some sort of a sustained casing pressure. And we do have a huge market for surveillance for well abandonments, where looking for potential porous and permeable zones of flow behind pipe, where the thermal responses or acoustic responses are quite large, that having a really sensitive instrument, quite high-end instrument, is quite a bit of overkill. I think back to the days, my early days in the industry, when we had things like echo meters, and those things for monitoring fluid levels in wells were really simple things, small portable units that could be run on in a well, multiple wells. Somebody drives up with a van, connects it onto the well, makes the measurement, moves on to the next well. With a lot of the high-end units, that's quite difficult to do, and it's probably not very cost-effective. But what the approach that we've taken is to try and encourage the development of these low, these simple to use, simple to operate, self-contained units that are designed to move from place to place fairly readily. So this particular unit that we've got is, it comes from an OTDR background and optical systems monitoring pedigree. And so they've had multiple years and decades of making robust boxes for field use. And that, to me, is a key selling point of these types of units, is small, light, portable, battery operated, self-contained, really simple to use. And if necessary, you can control this with an internet connection over the phone and do everything over your mobile phone or your laptop. And so that's an end of the spectrum that was not necessarily being catered for by some of the more complex high-end boxes, which were aimed at a different sort of market. The big data problem, we've all heard about DAS data volumes. Most of the DAS box manufacturers have their own versions of decimation, fast Fourier transforms to decimate that data into something a little bit more manageable. Quite often you still need to take that data back onshore to an office. If you were performing a high-end application, there are many ways of trying to improve the quality and extract yet more information out of that. And that's not really what we're about in Solar Sense. We're interested in just simply getting the data decimated, not performing anything particularly fancy on it, but for the types of application that we want to do around leak detection, it has to be fit for purpose. And so keeping the processing as simple as possible, as quick as possible, is the name of the game as far as the type of market and customer that we're trying to drive towards. So if my mantra here would be, if I can't teach somebody to use the surface acquisition unit or the software within an hour or two of training, then it's too complicated. And we have to remember that in this industry, we have lost a lot of talent, and we've got a lot of new people coming in, and not all of those people at the well site will be running these jobs all the time. And so to access or to open this up to a much wider well population, the processes and the workflows and the applications have to be a lot simpler to use. And in its simplest form, the big data problem boils down to where is the data file and where do you want the results sent to. So as long as somebody can navigate a browser to point to a data file and navigate to where they want the data to finally end up, then the system will work on a default setting. And then that means that I don't need to have a particularly skilled person at the rig site to ensure that we're gathering the data appropriate for some of these lower end type applications. So how do I integrate the data? And this was another frustration in that there were a myriad of different systems for the case tool log data, for the OpenHole log data, for the DAS data, for the DTS data, and for a low-end type application. All I want to do is to be able to show all the relevant data on one page at one time. And it has to be simple to use. It cannot be complicated. And again, what we have here is an application called QuickView, which is designed to be really user-friendly. It's very much a point-and-click type application where I can pull in my normal log data. Here it's a Gamma CCL, but we could also pull in data from OpenHole or process data, porosities, permeabilities, water saturations, and display those. Memory data, it could be a downhole pressure gauge, but in this case it's a memory pressure temperature gauge run at the bottom of the fiber on this track. Then something about static information from the well, casing points, completion elements, could also be formation tops. And finally, they distribute acoustic data, and this is one image of a multitude of images. So one of the things that we've found was, or I've always found when I'm looking at acoustic data, is there are multiple different settings that I could apply. And I was constantly having to go back and reprocess and recalculate things to try and modify the image. But the approach that we took was to have a matrix of settings that we would apply to all the data all the time. And when I import this data, this is one of maybe 100 images, and I can scroll through to see how each of these features appears or disappears with different settings. And that allows me to do a much more comprehensive analysis. And then finally, the temperature data. And again, there are multiple views of the temperature data where I can look at difference plots or successive difference plots or depth versus time, etc. So having all of this on the one page at the one time allows me to diagnose issues within the well. And in this particular case, there happened to be a leak at one of the side pocket mandrels, and we can clearly see that in the acoustic data and also on the temperature data. And so by manipulating the tubing and annular pressures, we could induce flow from one to the other and measure that on both temperature and acoustics to absolutely nail what was wrong with the well and how the operator could go back in and swap out that faulty valve for a new one and restore the well to production. Now, again, we've been into many wells where there's been 8 or more side pocket mandrels, and if I had a conventional logging tool, if I wasn't opposite that side pocket mandrel at the time the leak was induced, then I may not spot it. And so again, that's the benefit of looking at a distributed measurement over the whole well, to try and make sense of what's going on with this data set. The other benefit is we also have surface temperatures, surface pressures that we can look at and monitor the flow at the surface as well while we're performing well manipulation, and then look at pre and post static interfaces in the tubing, and then work out what's happening with the well hydraulics. So again, a very, very rich data set where a combination of the cased hole data, the memory log data, the temperature and the acoustic data all come together to give you a coherent story. But really, having these things as separate displays doesn't really help a user or an operator judge for themselves what is wrong with the well and what the route forward should be. So speed, quality, and cost. So most operators will demand a fit-for-purpose answer as quickly as possible and at a reasonable cost. I think back to my days on the Forties field in the North Sea, where if we ran a production log or a pulse nuclear log, by the time that tool string had reached the surface after the survey, I had to have a fair idea as to what was wrong with the well and what we wanted to do with that well during the same rig up, so that we could then swap out the tool string for either a plug or cement baler or perf guns or whatever it was. And there has been worries that because fibre is such a huge data set that it's not possible to have a quick turnaround. Well, it absolutely is. And so the aim should, I've always tried to make the process as simple as quick as possible to allow me to come to a decision as to what's wrong with that well by the time the deployment mechanism for the fibre is back to surface and rigged down, so that they know what to rig up with to solve the issue. And so that's the speed of turnaround that we should strive towards. Now, is that going to be a perfect solution? No. So it's good. It just has to be good enough to make a robust decision on the well, but then during the following week, you can maybe tidy up the data and for reporting purposes, or you may have to go to a higher end type functionality to try and squeeze out more information from that same data set. And it's fair to say that what we're offering is very much a viewer of the data for a quick look of the data and for fast decisions. It's not something that is involving any high-end numerical work, any inversion of the data. You're not going to get seismic quality out of it, or you're not going to get any flow quantification out of it. So it's very much a qualitative rather than a quantitative answer. And there are lots of perfectly good applications out there for doing quantitative high-end work and that's not where the arena that QuickView is playing in. It's very much here is something that can be used by a fairly inexperienced person with a lower level of skill and training to come up with a robust answer. So the minimum of experience and training required prior to the capture of the data, and then the minimum of experience and training to use the software, because I need quick solutions that at a reasonable cost, and that's what we're aiming for. So we do have some training classes that are going to be offered in the future. So I think Marvin will issue some notifications about that. I'm always struck by there's a lot of quite basic questions that people ask about fiber optics, deployment methods, interrogation units and boxes. People are just simply not used to this, and so there is a knowledge gap that needs to be bridged before they get comfortable with what this measurement system is trying to do, and before they buy the services. So what we want to do is to offer both field personnel and I wouldn't go as far to say log analysts. It's for people who have a vested interest in the data. So you don't need to be a log analyst. You could be a petroleum engineer, a production engineer, a petrophysicist, or a reservoir engineer. But you need to be familiar with the types of measurement that we're trying to get, how we get the fiber in the ground, and the various deployment methods that are available on the market, and the pros and cons of those, the different units that are available, both DAS and DTS units for different applications, and as I mentioned before, the unit that we have in SolarSense is very much a field portable unit that is really simple to use, self-contained. It's not going to be as sophisticated as some of the much higher end units, but I know that I can apply this small portable unit to quite a wide range of well integrity type applications. So again, that's the market that we're aiming for fairly and squarely. And then finally, the interpretation and processing. If you only want to view the data, then we're quite happy with the product and methodology that we've developed. But for any form of higher end numerical work, then you have to look towards other applications that are much more sophisticated, but then require quite a bit more training and skill to use. So we will be offering these classes in the near future, probably first quarter, second quarter next year. So stay tuned for that. And with that, I think it's just about 35 minutes, so loads of time for questions. I've kind of rattled through that fairly quickly, but those are the go well locations globally for those that want more information on any of these systems. So Marvin, we'll shut up.
Thanks, Mike, for that. That's pretty to the point. We're open for any questions that anyone may have right now. I think you can type those in. There's a box, I think, on your screens to do that if you have any questions. As I say, at the end, there will be a little email going out with some feedback. So you're very welcome to contact us if you want some more information. But I think what Mike has outlined there. There is some some gaps in understanding in this technology, we believe, in the market. So this, we think, is the going to be the first of the webinars that we'd like to put together. So we're certainly open to hearing from people about what they'd like to know more about this technology. So is it in the applications, and as Mike mentioned.
So any questions? Can't see any.
Rich data set. So that is, that does require some about. much more dynamic. Definitely have to think about that. So there's some questions coming in right now. Let me have a quick look here. Yeah, someone is asking about presentation about more fundamentals. I mean, there are multiple directions that that can be gone here. So what we are contemplating is further webinars. One on, for example, the acquisition. So the hardware, the boxes. You know, what does it? You know, what's the difference between the different type of boxes, single-ended, double-ended installations, etc. So clearly today we weren't addressing all of those points. But if you see a need for that, then you know, definitely let us know. So we see potential around, okay, how do you get the data in more details, and what's the pros and cons of the different types of installations or different types of single mode, multi-mode fiber, etc. So that's one topic, that's the nuts and bolts. How do you what do you understand about the dynamics of the measurement? So viewing the data in software, looking at DAS data, as Mike mentioned, about different panels. Basically, they're either at different frequency bands. What does different frequency band can tell you, and what do you see? Such as the noise being transmitted up and down the casings. How does that look? How does bubbles rising in the well look, etc. So that's certainly, there's another whole topic around interpretation of the data, and where does a webinar transition to actual training class, and that's what we had touched on earlier. We do see a need for that. Mike didn't mention, but he's actually going to be the presenter for a new PetroSkills class that's debuting next year on this topic. So this is all part of what we see as gaps in the market, or gaps in knowledge, should I say, that are out there in the industry.
Yeah.
So
Marvin, if I can just chip in there.
Go ahead.
I really can't stress enough that the bulk of the questions that I get asked when going around different operators or service companies for that matter are all actually fairly fundamental questions, and it's just, there is no training offer out there that says, look, here's all your choices that you've got available, and how you winnow these or sort those out down to things that are applicable in your situation. And it's in all of the service providers' interests to get the knowledge level up in the customer base. Otherwise, they're always going to be sitting on the fence, not actually buying the product, which it doesn't do anybody any good at all. So there's a huge knowledge gap that needs to be filled. And so any opportunity that we've got to try and evangelize on fiber optic sensing and surveillance in general, we've got to take it.
Okay, thanks. Yeah, there was a question about training schedule. Right now we're targeting for later part of Q1 next year to put together a class that would cover both parts of the topic we mentioned here, which is actually handling the acquisition of the data and handling the fibers, and then a portion that would be related to analyzing the data and interpreting the data. So again, we're interested to hear feedback. What do people and how would it be separate, different people involved? So and in terms of geography, again, that's not been decided yet, but probably an Eastern Hemisphere focus and a Western Hemisphere focus in separate classes. We are trying to build these fit for purpose classes. So feedback is certainly welcome. There was a question, I think, here from Prakasan asking about the interrogator. Is it fully commercial now? I think, Mike, you can answer that, but as far as I know, it is, and we're already using it. So.
It is fully commercial now, and I think last time you saw it, that was the prototype version, and so there's been a few modifications to the how it works to improve the quality of the measurement, and we're quite happy with the performance and quality of the unit now. So yep, fully commercial, which is why we ended up signing up with the GoWell because obviously we're SolarSense itself is extremely small, and we're all working on the technical aspects of it. And so GoWell has a much broader global footprint and can support global deployment.
Okay, thanks, Mike. There was a question about case studies.
Okay.
I think that is a good question. I mean, I think that needs more time, and we are contemplating having another session that kind of focuses a bit more about the examples.
Yeah. So the case studies are every time you go into a well, you always find something that you didn't expect, or something that you did expect wasn't there. The case studies are really, really interesting. We've got quite a few different case studies that we could potentially show, depending on the types of topics that people are interested in. Now, working in Europe, then most of the case studies I've got available to me all tend to be well integrity or completion integrity or abandonment type applications. But it's incredible how things are starting to take off with fiber monitoring, and so we're getting more and more examples from further afield, and certainly as we start looking at the North American market, they've had lots of stimulation type case studies, which I'm not. I tend to like the leak detection, flow assurance type things, just from a personal perspective. But yeah, lots of those that we can go through.
There was a question here regarding combining DTS and DAS measurements in one cable. I think usually the cables themselves have both multi-mode and single mode fibers, or multiple single mode fibers in one cable. So you may want to comment on that, but as far as I know, it's certainly possible to acquire DTS and DAS simultaneously with one cable.
Yeah, and in fact, I've got a very strong preference that both DAS and DTS measurements are acquired all the time. Just having the one, I'm always a little bit uncomfortable with having only the one measurement available to me. I'd much rather have both measurements and have some sort of memory data or surface readout data from sensor package at the bottom of the fiber as well. The more data you can bring to bear on a problem, the more unique the solution will be. And so in all the jobs I've been available or worked on as a consultant, it's almost exclusively been multiple both DAS and DTS on the same cable or wire, and that tends to be the norm. It's amazing how sometimes it's the temperature that gives you the real strong diagnostic answer, and sometimes it's the acoustic. but it's best if you acquire them both, and if both of them are telling you the same thing, then that's a very, very compelling piece of evidence.
Right, and I think it's again, this is a topic for discussion more in acquisition, either in another webinar or some training. But the question was here about multi-mode and single mode. We're offering a DTS measurement that also runs on single mode fiber, which is the same as DAS. So but we also have a multi-mode DTS available. But typically both fiber, in one cable there are both fibers available.
Yeah.
There's another question about please can you confirm the fiber optic cable properties recommended in your application? I think that's more or less the same. The small portable unit that was shown in the slides today runs on single mode fiber optic cables, or the fiber in these cables. But the software that you're showing, the Quick View and Hot DAS, this is not limited to any particular acquisition. So you can take data from any DTS box, has been done and can be done. So the software here, Quick View, can use any can integrate any data from any DTS box and of course other data. And Hot DAS is able to take any DAS data to process. So we're not actually limited to any particular hardware.
Yeah, I mean, I think on that score, because there are so many different DTS boxes and there are a number of DAS boxes, if we had if it was a box that we hadn't had access to before, then we may need an example file so that we can get the right. Here's the start of the data, and just in terms of the extraction of the data from the file itself. But yeah, it doesn't really matter how the data is acquired for the types of application that we are using, because we're using quite a simple approach in terms of decimation and then display. Again, it's a viewer of the data. We're looking for relative changes within the system. If I wanted to go to a higher end application, a seismic type application, or one of these higher end type things, then it would matter how the data was acquired, what fiber it was, what type of deployment system. There's a lot more considerations, but when you're looking at that type of thing, then it's a far more involved process to extract that higher quality data out of the measurement. But then that's again not what we're about. We're about really quick turnaround of information for fairly simple flow assurance, well integrity type applications, where we don't have to have a degree of sophistication. The other aspect is the actual quality of the fiber itself. I mean, the fiber optic darts that are available on the market, those use standard telecom grade type fiber. It only has to last as long as the duration of the survey, and that's very, very cheap because they're manufacturing a huge volume of that for standard telecoms market. But for permanently installed systems, then obviously you have to be very careful about protection of that permanent fiber in a hostile environment for hydrogen darkening and various other effects that would cause you issues.
Okay, thanks. There was a couple more questions here related to well, one question related to interpretation services. So, what we were presenting today was, obviously a general introduction for the equipment and the software. These are being provided on a sales or rental basis. As far as doing interpretations, that's something we can discuss separately. Again, it depends. We want to understand what the market needs, what are the, where are the gaps, but we do have, we do want to be able to provide, what's necessary to make this technology more ubiquitous. I think, what I didn't mention at the beginning is that, one of the drivers here is, is not only to make it, faster and cheaper, as Mike has pointed out, and that would lead to be more ubiquitous. So, people, rather than being novel and something you've heard about but actually haven't used, that's kind of how it is today. Whereas Slickline and Wireline is ubiquitous, everybody knows, and that would be your first thing you write up a tender for, or the first thing that you call for services for. One of our mission statement here, as it were, is to make this more ubiquitous, make it a mainstream way of being able to acquire data, so that it's more available. And so, how to do that? That's what we're hoping to hear back from the range of people in the industry, to understand, what's the roadblocks and what do they need to make it more ubiquitous.
I think Marvin, on that score, that's one of the reasons why in my latter days in BP I got really interested in slickline deployment and fibre optic dart deployment, mainly because almost every rig on the planet will have access to some sort of slickline capability, and so if it does get to the stage where fibre is a normal part of business and is available globally, then we actually have a huge problem in the industry, because if it's all high-end applications and high-end software and skilled interpreters, we haven't got enough people to process and interpret that volume of material. So what we need to do is to make the software the software and the interpretation as accessible to individuals and operators as possible. And so it cannot be hard to use. And my thinking is, as long as I can get an image in front of a person, they know their well stock, they know their fields, they know what's brought down their wells and fields in the past, the types of problems that they've encountered. And so they're the best person to interpret that. And I just have to make the stuff available to them, and then they'll be able to work it out. So they don't need to come to me for processing and interpretation. Now, maybe for the first 2 or 3 wells, before they get the hang of it, fair enough. But after that, it's got to be simple enough that they can do it themselves.
Okay. Thanks. There were a few people saying that they had some bad signal and couldn't hear the voice. So this presentation is actually recorded, so we should be able to make that available. Hopefully, that will fill in the gaps for some people that couldn't hear everything. We are coming up to the hour now. Just as far as questions asked, they were the main questions that I can see here, just going through. We'd certainly welcome anyone to send us an email if you would like to hear more or understand more about what was presented today. Again, thank you for joining, and look forward to hearing from you further. And as I say again, there's a little survey at the end in the email that goes out at the end. So please just take a minute or two to complete that. That will be very helpful for some feedback. Anything else, Mike, you want to say?
No, just thanks for listening in, and it's very high level, but hopefully we'll stimulate more interest in the topic, and we'll get a much wider population of people involved in distributed measurements and make this just a routine part of business, because just now it's not, but if we really push to hard, we'll be able to get the knowledge level up, the comfort level up, and a heck of a lot more surveillance in our well stock than we're currently gathering now.